Good morning, everyone. My name is Rebecca Weiss, and I am the Executive Director of MLCommons. I'm sorry that I couldn't join you all in person today, but it is my pleasure to welcome you to the launch of our AILuminate benchmark. For those of you who may not be familiar, MLCommons is an open AI engineering consortium that is built on the belief that trustworthy, safe, and efficient AI depends on better systems for measurement and accountability. You can't trust, let alone improve, what you can't test. And we believe that when we start measuring things, they tend to improve. We are also grounded in the philosophy that to improve AI, just like any other type of complex technology, we must work together. No single organization or entity has all of the answers. Instead, this work can only be done by leveraging the unique expertise and perspective of academia, industry, and civil society. The first step of reaching a goal is agreeing on what that goal is. That's why, since 2018, we have brought together academic and industry resources to create trusted, empirically sound AI performance benchmarks. And now, with roots in well-respected research institutions, an open and transparent process, and buy-in across the industry, we are tackling the urgent issue of AI safety. So today, you're going to hear much more about AILuminate. This is MLCommons' new benchmark for measuring the risk and reliability of large language models. This is a major milestone, not just for MLCommons, but for our global community of academics, industry leaders, and advocates that are dedicated to safer AI. To our partners, our supporting companies, and of course, all of the members of our Risk and Reliability Working Group, all of whom made this happen, thank you so much. I'd also like to thank the incredibly talented members of our MLCommons team. This achievement would not have been possible without you. So, we are thrilled to share AILuminate with you today, and we look forward to continuing to partner with you as we develop and advance a global baseline on AI safety. And with that, I'm pleased to welcome MLCommons founder and president, Peter Mattson.
Good morning, everyone. Thank you all very much for coming. A few quick logistics. Please turn off your cell phone or mute your cell phone if you haven't already. And if you need it, the restrooms are that way. I want to start this morning with a quick crowd check. So please raise your hand if you think AI safety is important. All right, great. Please raise your hand if you think we have AI evaluations figured out. All right. We'll make the rest of this talk easier. So I'm presenting today AILuminate version 1.0, which we view as a first step towards a global standard for AI product safety. This is work by, as Rebecca was saying, a lot of talented people, in particular the MLCommons AI Risk and Reliability Working Group and the AI Verify Foundation. I want to start by talking about AI progress and the challenges we face today. So for a long time, decades, AI was a bunch of very cool ideas that never quite worked. But now we've entered a new era, which I'm going to describe as the era of amazing research and scary headlines. And in order to get there, we had to break through a barrier, a capability barrier. And we did that with innovations like deep neural networks, like transformers, and benchmarks like ImageNet. But today, we want to reach a third era. And that is the era of products and services that deliver real value to users, to businesses, and to society at large. And in order to get there, we need to pass through another barrier, a risk and reliability barrier. Imagine the best AI demo you've ever seen. Now imagine an AI system that could do that every single time in real-world conditions with very low risk. That is where we are trying to go. We've seen this before in other industries. So if you look at aviation, for instance, you can look all the way back to the sketchbooks of Leonardo da Vinci. Great ideas that never quite worked. And then you see the breakthroughs that make them possible, like the Wright brothers at Kitty Hawk. But there was a tremendous amount of work from that first flight to the almost unbelievably safe commercial aviation we depend on today. Many of us in this room wouldn't be here if not for all the work and the measurement that enabled that progress to a highly reliable, low-risk service. To get here for AI, we need standard AI safety benchmarks. We've seen benchmarks drive progress across industries, whether it's new cars, the safety of automobiles, the environmental quality of buildings, hospital quality. We've also seen this firsthand at MLCommons. So MLCommons got its genesis from the MLPerf benchmark. So MLPerf is a measure of hardware speed and software stack speed. And what we've seen since the introduction of that benchmark is a 50x speedup in 5 years. So this graph shows different parts of that benchmark getting faster over time on a logarithmic scale. The dark line at the bottom is Moore's law. So this is an incredibly fast ramp. And the question is, can we do this for safety? This is what we're trying to achieve with AILuminate. AILuminate is aimed at what we describe as AI product safety. So it's worth talking about what that means, because AI safety means a lot of things to a lot of different people. Product safety is hazards from users of AI systems or hazards to users of AI systems. Near-term, practical, business value-oriented, that's product safety. There are other important aspects of AI safety that other folks are looking at. This includes frontier safety. So this is what happens if the models get too smart. Autonomy, advanced CBRN hazards, things like that. And there's also social safety. There are real economic and environmental risks around the development and deployment of AI, and these are conversations that we should be having. But what we are focused on is that product safety. And in particular, in this first version, this first benchmark of what we plan to be a growing family of benchmarks, we are focused on general-purpose chat systems. So these are systems that you interact with, this is ChatGPT. You interact with it by asking it questions, asking it to help you do things, most of which are good things, some of which are not. So you ask it how to kill your boss and not get caught. The system considers that, and it's going to give you one of two types of answers. It's going to tell you that killing your boss is wrong, or it's going to give you, 5 easy ways on an Amazon shopping list. All right? We would really prefer that it give you the green box answer. And we want to measure that. Specifically, we want to measure this quality of giving the safe answer to a hazardous prompt for 12 different hazards. So here are the 12 hazards. They fall into roughly 3 bins. So there's physical hazards, things that involve hurting others or hurting yourself. There's non-physical hazards, IP violations, defamation, hate, privacy violations. And then there are contextual hazards. Contextual hazards are things that in a non-general purpose application might actually be okay. But you don't want a general purpose model giving you legal or medical advice and not disclaiming, I'm not a lawyer, you should consult an expert, at least. Or producing adult sexual content. So these are the hazards that we check. Our goal is to develop a benchmark that not only checks these hazards, which produces a lot of useful information, but distills that information into actionable grades, something that a non-expert can actually understand and reason with. So we produce grades for the system under test overall and for each hazard on this 5-point scale, from poor to excellent. And if you understand one thing to orient you with respect to this scale, it's that good is defined by being competitive with the 2 best accessible systems we tested. So when I say accessible, what I mean is systems with less than 15 billion weight, so you can run them on reasonable sized pieces of hardware, and relatively open licenses. These are things anyone can get. And the analogy I like to make is this is equivalent to centering good for automobile safety on the safest economy cars. So we want to define a standard that is accessible to people all around the world in different size organizations. And these are models that they can get and work with. So keep that in mind, that good is accessible systems, and that the definition of a safe, accessible system will advance over time. A safe economy car of 20 years ago is not a safe economy car of today. So how was AILuminate developed? I think this is important to understand before we plunge into the details. MLCommons operates open working groups for early benchmarks. That means anyone can join. This is a particularly large open working group with 8 different working streams looking at different aspects of the benchmark. We had contributors from 50 different organizations, from frontier model developers to universities, civil society, people who use models. We also had a strong partnership with the AI Verify Foundation. Talk about them more in a minute. And we had amazing engineering and other support from MLCommons staff, sort of as the glue that holds all the experts from these organizations together. We developed this benchmark in partnership with AI Verify. AI Verify is a foundation in Singapore. They're focused on AI testing and assurance, trying to create a trusted ecosystem, so very well aligned with MLCommons goals. And they're a subsidiary of Singapore's IMDA, so they have a really good insights into the need of policymakers in this space and into the APAC region in general. So very valuable partners for this effort as we try and make it global and standard. So how does AILuminate work? Here's the flow. We start by clearly identifying the hazard categories in our assessment standard and by providing guidelines for how you decide whether a response is a violation of a particular hazard. From those hazards, we produced 12,000 prompts for our practice test and 12,000 prompts for our official test. To run a test, we pass all of those 12,000 prompts through what we call a system under test. This could be a model, or this could be a model plus some other things. We get a whole bunch of responses out. We pass all of those responses through our evaluator model, or in reality, an ensemble of evaluator models that tell us if they're safe or not. And then based on those evaluations, we produce the grades and present them in a nicely accessible report. So what makes this different? There are other safety benchmarks out there, a lot of really great ideas coming out of academia, like the folks from Helm, who've been great partners since the beginning of this. We're trying to fold all of those ideas into a production-level benchmark. So in particular, this effort is supported by a broad open group with academia, industry, and civil society. We have a clearly defined assessment standard. These are the hazards we are measuring. This is the responses to prompts that exemplify those hazards that we consider acceptable, and the responses that we consider unacceptable. We specifically do online testing with hidden prompts for our official scores. This is important because if you show a model, even inadvertently, the prompts in your benchmark, it's like showing a student the questions on the exam before they take it. Their performance on that exam will not generally be indicative of their actual knowledge. We also do hidden scoring using that ensemble of models. So this is a specialized artifact that the MLCommons team has created. And this is also important because the evaluator that's used to rate responses, if you include that in your system, you can hide all the signal. It's like showing the system the answer key before the exam. We don't just produce numbers. Numbers are great if you're publishing a NeurIPS paper. If you want people who aren't experts to be able to make decisions, you need to give them something simpler. And so we provide clear grades, and then we back that up with numbers for experts who want to understand more. Lastly, MLCommons has been operating MLPerf since 2018 in one form or another. We are in this for the long haul. We understand that developing and operating benchmarks is an iterative and sometimes grindy process, and we are here to do that. There are limitations to this version of AILuminate. It's very important to be upfront with these and to understand them. First of all, it has limited scope. This version only targets text LLMs. It only tests those hazards I listed. It only does English. It's important to understand the scope of what it does. It's part of a complete safety solution. It also only tests single prompt response interactions. So this is, I ask it to do a bad thing, does it do the bad thing? And if you look at longer term, say, personal agent interactions, those might require a different form of testing. Any AI testing that involves natural language is high uncertainty. We sample prompts from an infinite natural language space. If we want it to be scalable, we use automatic evaluation, and that has error, significant error. And these models have temperature. They don't give the same answer to a prompt across runs. So these are significant sources of uncertainty. Lastly, this is relative grading. We think this is really the only practical way to do safety assessment in an early young industry. You have to assess relative to what you can build. But it's not an absolute statement about safety. People need to understand that. We can say these are safer systems. And lastly, and I cannot underscore this enough, this is v1.0 of a rapid iterative development. This is how MLCommons has always done things. Dave Patterson in the early days of MLPerf said, launch then iterate. And that has been our motto for a long time. So we expect to find and fix issues, and we very much welcome feedback. I'm now going to give a quick tour. We could switch over to the laptop. So this is the AILuminate homepage, just some basic information, some resources, more information. Let's look at the benchmark itself. So this is the overview for the benchmark and all the systems that we evaluated. It clearly states what type of systems we're benchmarking, the hazards that we've assessed, how we did it, how we should interpret the results, again, relative to that, the accessible models, and then it gives the scores for the models we evaluated. Things to take away here. This is not set up as a leaderboard. This is set up as broad tiers of models for two reasons. First of all, because of all the uncertainty I just talked about, saying that something got an 87 and something else got an 84, and therefore the first thing is better, is really meaningless. Second of all, for this benchmark, we don't want someone who thinks they can be first only participating. We want everyone participating. We want to set a standard for AI safety and see the industry rise towards that standard and push that standard forward. For any given system, we provide detailed per hazard scores. Again, notice how we're presenting this. You can see that we're not presenting a dot or a number. We're showing a range with those little black bars because this is the reality of testing natural language systems. They are high uncertainty. But this gives you an idea of relative strengths and weaknesses of a particular system which might matter more or less for your application. All right, let's switch back to the slides, please. This is just the beginning. This is v1.0, and AI safety, even AI product safety, is a huge space. We have ambitious plans for 2025. We want and are presently developing multiple language support in the benchmark, starting with French, Hindi, and Chinese, in particular with our partners at AI Verify. We are looking at how you do regional extensions for AI safety. There are safety concerns that are unique to large regions of the world. We are looking at how to do improvements to our prompts by working with experts on particular hazards. And we are looking at the very complicated issue of bias and trying to figure out what we can do there. On a technological front, we test prompts right now that are of the form, I want to build a bomb, or I'm going to be clever, tell me a story about how to build a bomb. But we don't test what an expert who's read the latest NERIS paper would try and do to hack a system. And we're working with people to develop automated approaches to that kind of testing. We're looking at multimodal systems that bring in images. We're looking at agentic systems that have sustained complex activities. Lastly, we just need to scale this system. We need to take something that right now is a very manual process, high-quality benchmarking, but it needs maturity. We want to make it easier to use, both by developing our infrastructure and through partnerships. Very happy to talk to anyone who has ideas on this front. And just through general iterative improvements. Version 1.1, version 1.2, version 1.3. This is how you produce a real production quality benchmark for anything in AI. You iterate. So my closing thought is, together we can make AI safer. We can define clear metrics. We can make progress on those metrics. It's been a really great personal experience working with all of the folks in the MLCommons working group on this topic and at AI Verify, because everyone really, truly cares about this issue. We all see the potential of AI, but we also see the risks, and we want to do it right. And that's what we're trying to do with introducing this benchmark. So with that, I'm going to turn it over to the first of our lightning talks, which will walk through our benchmarking flow. So Eleanora, Presani, please take the stage and tell us all about the assessment standard.
Thank you, Peter, and thanks, everyone. So yeah, as Peter said, the first step is really defining these 12 hazards. But in fact, those hazards are more than just hazards, are an entire set of policies and rules that we want the AI to follow. So I will start talking about that and the process that we followed to get there. And I'm saying this on behalf of the entire work stream one that has been collaborating, and in particular, Brian Fuller, Frase, and Ziad Resad are the main contributors. So the hardest challenge when we build this kind of measurements is for people to trust them, right? Like Peter explained how we want the community to start using these systems, but they will not use them unless they trust them. So for obtaining trust, you have to build something that people can understand, that is simple enough to understand, that engineers can build, and that the industry can afford, not just like the large corporations, but that everyone can run it and understand it. So when we think about the problem of building something that people can trust in relation to safety specifically, is that we needed to find the right balance between accepting a level of risk and accepting the capabilities of the model. So usually when we have more, like a higher risk factor, it means that the model is more capable. It can answer more things, it can achieve more stuff, but some of this stuff is going to be dangerous. On the other hand, if we create a black box that always answers no to everything, it's going to be, by design, super safe, but it's also going to be completely useless. So finding this balance, it's really like the key to success. Besides the risk factors, also understanding the cultural expectations of everyone in the world is also a big challenge. So when we decided to create policies that follow regulations, we necessarily need to understand which regulations we want to follow. So it could be that we go for a hyper-local approach in which we create a billion different benchmarks for every single city or region in the world or cultural group. Or we can decide to have a one-size-fits-all and expect the entire planet to follow our rules. Obviously, both of these approaches are not really functional, right? The hyper-local approach is not a standard by definition, and it's also very difficult to implement, if not impossible, if you wanted to build a model that is released internationally at the same time. On the other hand, the one-size-fits-all is going to make a lot of people unhappy, and they will not feel represented in the set of policies that we are building. So to find the right balance for that, what we did was to try and follow the approach of normative laws that are an approximate set of policies that have been suggested for recreating a society when a society breaks down. So it really comes down to the basic of humans' expectation for mutual respect and mutual safety. So the result is the 12 categories that Peter mentioned that are represented here. So we have like physical and non-physical hazards that we are expecting every system to abide to, because we always want systems to not create hazards that can be of physical nature or non-violent nature to people. And then we also added, for now, just two of what we call contextual hazards. Contextual hazards mean that are hazards that are not always hazards. It really depends on the situations and the context where they are appearing. So, for example, sexual content, it's something that if you are building an application that is aimed at children, you probably don't want the sexual content to appear and you will consider it an hazard. But if you want to create an entertainment application for adults, then maybe that is an okay thing to have. So it really depends on your application, and what we are trying to do in the way that is also displayed in the results that Peter showed is really give the power of interpretation to the users that will understand, okay, this hazard is really a problem for my application and therefore I need to do something about, or not, or vice versa. One thing that also to consider is that the prompt types that we have been using to do the testing for these categories are of two types. So far, it's the naive users, so someone that is not trying to break the model or do anything nefarious, but might receive a hazardous answer. And that is really bad, right? Like, this is really what we want to avoid, and therefore it's important to test. But the most frequent situation is when people are trying to misuse the system. And then, so that is what we do with the knowledgeable users that understand how to prompt models to try and obtain what they want around the safety measurements. So the taxonomy is more than just a taxonomy. It's not just a list of things, but it really comes to what we call the assessment standard. It has three main components to it. One is indeed the taxonomy. The other one is the definitions that we are, of each single word, basically, that we are using in taxonomy. When we say things like endorsing, or promoting, or accepting, what do we really mean with these words in a way that people can understand, and if you need to create new annotations, you can always go back to the policies that we have written. And then a guidance that is really much more detailed on how to create the prompts and how to evaluate the responses at a really more detailed point with examples and such. And then for the next part, I want to introduce Shaona that is going to talk about the evaluators.
Thank you, Eleanora. Okay, good morning, everyone. So it's my great pleasure to talk about evaluator systems that we built for this benchmark on behalf of the AI Risk and Reliability Working Group. It's my pleasure to introduce Ryan, Kurt, Tyler, Shachi, Rajat, and Rajat Ghosh, and Saurav, who worked with me in this development. So we will start with explaining what evaluators are. So as we've heard before, any benchmark has some fundamental components. We start with, in this particular benchmark, we start with taxonomy and set of guidelines that assesses whether a particular hazard is violating or non-violating. We also have another component, which are the prompts that are uniformly distributed across different hazard categories. We have a grading system that assesses the hazards and produces a final grade or a final score or a report to the system that's being tested. And one of the more fundamental components is the evaluator. That actually is an automated system that assesses whether the system being tested is producing something that is unsafe or safe. So if we look at the flow of the data or risk, what have you, so if we look at the data flow or risk flow, the first component is prompt and taxonomy. That gets fed into the system under test, or the system being tested. In this case, it's an LLM that produces a response to the prompt based on the taxonomy that the prompt adheres to. The system under test produces a response, and the response then makes its way to the evaluator. The evaluator produces labels, whether the particular response is safe or unsafe, and if the response is unsafe, it produces a set of hazard categories that are violated for that particular response. The safety labels then makes its way to the grading system that produces the final score, and that's the report that's going to be made available to the systems that are being tested. So when we designed this evaluator, we had to keep in mind certain design principles. So we wanted to have evaluator model backbones that are not developed by one organization or does not support just one model backbone. We wanted to include machine learning backbones from various different organizations so that it's neutral, and the neutrality is taken care of at every step in the process. We also wanted to look at what data was used to train these models and what the data provenance looks like. We wanted various different model backbones produced by different model providers. We wanted to create evaluator systems that can be competitive with state-of-the-art. In fact, we wanted to advance the state-of-the-art in the data and the data distribution that we are interested in for the metric of interest that we are tracking. And we also wanted to not have a single point of failure in the entire system. We wanted multiple evaluators to diversify the risks. So keeping those design principles in mind, we had this development strategy. So if that's the flow of the data or risk, and that's the evaluator, we looked at the whole spectrum. On one end of the spectrum, you can have an evaluator who's a human who looks at the responses and assesses whether it's safe or unsafe. Now, obviously, doing that for every single such response and every single prompt is not scalable. Also, human annotations have been shown to be inconsistent at times. It's also not very flexible. So on the other end of the spectrum, we can look at automated systems or machine learned systems. We have pre-trained models that are available off the shelf. A lot of LLMs, as we know, or even safety models like LlamaGuard, WildGuard, and many other safety models. These are trained on either synthetically generated data or open source data sets. Now, the problem with those models is that they will not produce the exact same measurement or score on our metrics of interest because they are not super performant. They have been trained on trained with different taxonomy. So we wanted to take the middle ground where we fine-tune our own custom evaluators using our own data and our own taxonomy, but also leverage the other end of the spectrum. We wanted to leverage pre-trained model backbones. We wanted to look at synthetic data and the quality that it brings with it. We also wanted to look at human annotations and obviously the quality that it brings along with it. So now training an evaluator is not a trivial task. One of the most fundamental problems in training a model is the training data set. Now, AILuminate has this amazing set of prompts that comes with it, but we don't have the responses. Now, for training a model that can judge the safe and unsafe characteristics of a response, we need both prompts and responses. So we need to be really careful on how we generate the responses, what are the system under test or LLMs that we choose to then produce the responses. These systems under test would be very different from the ones that are being tested once the benchmark is released, because we wanted to have unsafe responses in the training data set, because then the model will know how to judge between safe and unsafe. So therefore, it was also interesting to elicit unsafe responses from LLMs. A lot of the LLMs are now currently safety aligned, so they won't produce unsafe responses. So we had to think out of the box of how we generate unsafe responses for our training data set. Additionally, we wanted human annotations, but we know that human annotations takes time and it's risky. So we wanted to, in the absence of human annotations, we wanted to look at synthetic labels so that we can make progress and iterative developments while we wait for the human annotations. Now, how do we measure the evaluator? We need to evaluate the evaluators. So we needed a human annotated, high quality ground truth data set. And we also needed a metric that we would track. Now, as we know that a lot of these LLMs are considered very safe unless you elicit certain responses in certain type of prompts and malicious prompts. So we wanted to build evaluators that if a certain response is unsafe, the evaluator doesn't make a mistake. And so we wanted to actually optimize on the false safe rate so that the evaluator doesn't accidentally make a mistake on classifying an unsafe response as safe. So that was our metric of interest. So now, with those, we wanted to track the milestones that we've achieved. We started off with version 0.5 evaluator back early this year, and that was a pre-trained off-the-shelf evaluator that did not use MLC's own data set and did not use, obviously, the version 1.0 taxonomy. So we started with pre-trained state-of-the-art LLMs and safety models. And what we did is we prompt engineered these models with our version 1.0 taxonomy and tried to get the responses and measure the responses and the scoring on those responses. What we found is that those models were not performant on the metric of interest if you just take the off-the-shelf safety models or LLMs. So therefore, we decided to fine-tune our own custom evaluator models using the data set that we have and we have curated using prompts, responses, and safety labels. And doing that allowed us to actually achieve the kind of false safe rate that we were interested in. Eventually, we did have the human annotations, and we are currently training models that are being trained on these human annotations, and we will push those models out going forward. So as we wanted to avoid a single point of failure, we created an ensemble of individual evaluators. So each of these evaluators, those were fine-tuned or prompt engineered, became a part of an ensemble. And the ensemble then produces a final label. Each evaluator produces a safe or unsafe label. It goes to the ensemble logic, and the ensemble actually takes all those labels and produces a final label. And now, if the final label is inconsistent, we send that label for human review and then finally produce the outcome, which is the final label for that response. So I think we believe we have achieved what we set out to do. In comparison to the previous versions, we've now built a fine-tuned evaluator model that has a configurable metric that we can track. We have diverse model backbones so that we're not reliant on one single model backbone. We have an ensemble of evaluators, which is scalable and configurable, and we have achieved a false safe rate that is significantly lower than the state-of-the-art, so we have pushed the state-of-the-art on our own data and our own taxonomy. Of course, it's not perfect, but we're going to keep iterating and producing better models as we go ahead. With that, I would like to thank all the contributors of Workstream 3, engineering, and the entire MLCommons, without whose help this would not have been possible. So thank you so much. It's been my privilege working with all of you. And I would like to introduce our next speaker, Dr. Heather Frase, for a brilliant talk on prompts, grading, and scoring. Thank you.
All right, hi, I'm Heather Frase, and I'm going to be talking on two parts of this flowchart that you see. I'm going to be talking about the prompt creation process and also about once we get those outputs from the evaluator, those binary outputs of safe or unsafe, how are those rolled up into a grade and then put into a report? And these are actually work from two different work streams, Workstream 2 and Workstream 4, which had a large number of people involved. There we go. Okay, here is a high-level overview of the prompt creation process. What we start with was just a request for people to submit proposals for creating prompts for us. And we had a number of proposals. Then various workstream leads ranked the proposals for different characteristics. Those were all rolled up into a high-level ranking, and then we were down-selected to 3 different suppliers for prompts. Those suppliers were then given the hazard categories, which Eleanora talked about, and also a lot of detailed guidance, which is one of the things that Eleanora also touched on. It's more than just a hazard category. It's detailed definitions, understanding of what makes a prompt fit into a certain category. And these are important to make sure we have good coverage of the hazard categories. So those were given to the suppliers. They then produced the prompts. They actually produced them in 2 batches. We examined all the prompts to make sure they had decent prompt quality, and then they were divided up into 3 data sets. There was the data set that's an open practice data set that anyone can now look at, or it's publicly available. There is also a test data set that's used internally by MLCommons for its work on the benchmark. And then there is the hidden data set that is not being viewed by anyone, is hidden, is used for official benchmark testing. And in total, there are about 24,000 prompts. Okay, so I touched on how we do prompt quality assessment. We looked at a variety of metrics and analytics. We considered semantic diversity, realism, external validity, making sure also that we covered all those taxonomy hazards was very important. Now, so we have our prompts. They get fed into the sets. They produce a response that then is assessed by the evaluator. And now we have to roll those binary outputs of safe, unsafe, or non-violating, violating of our policy into a grade. What we do is we start with a score, and then we use that score to derive a relative grade. For each system under test, there's an overall grade. But then there's also individual grades for each hazard categories, and this allows people to understand performance at a higher fidelity. The grades are all derived relative to a set performance, and Peter touched on this. There's to a reference set. Everything's relative to a reference set. And this way, are you roughly as good as, better, or worse than that reference set? Calculating the grade is actually pretty straightforward. We just look at the total number of responses and the total number of unsafe or violating responses. A score for each set is just those violating responses divided by the total of non-violating. It's a straightforward proportion. The relative score is just taking that score divided by the score of this reference set, and then you end up with your relative score. This process is the same for if it's the overall grade or if it's the individual hazard grade. It's just a question of what prompts and what responses you look at when you calculate those. For overall grade, it's all responses. For that individual hazard grades, it's just those that fall into that specific hazard category. Then the relative scores are binned, where this is pretty straightforward. You just get a score relative to how you are, right? If you're in with a certain range, you're considered to be performing basically the same as the reference set, or you're performing above, or you're performing below. So I'm going to talk now about ground truth. Ground truth is actually pretty important. It feeds into our understanding of the uncertainty of our evaluator, the uncertainty of our final grades, along with it's useful for training our system, the evaluator. The ground truth was derived by sampling responses from large language models and giving them to human evaluators to assess whether or not they believed they were unsafe or safe per our taxonomy and per our guidance produced. The annotation was done by a number of contractors again, suppliers. It went through a similar process for choosing those annotation suppliers as we did for choosing the prompt suppliers. They were given guidance on how to grade the responses, and it was done iteratively. We got feedback on how to, when things weren't clear, we would improve the guidance so that people could do better and have more consistent evaluations. And what they just did is they produced the results of this is violating or non-violating. And both of these things were done, and they helped us understand how to estimate the evaluator error, and were used to feed back into training of the system. All right. There are many sources of system error and uncertainty in our benchmark. There's evaluator error, which we believe is likely the largest source of error currently, but there's other sources like sampling variance or model response variance. Evaluator error, as I said before, was estimated and assessed using the human annotation process. And those human annotators basically provide information if something was a false unsafe or a false safe. And those we could use to feed and understand the uncertainty of our grades. Shaona pointed out, and I'd like to reemphasize, that we intentionally designed for a conservative evaluator system. We designed the system to have a higher false unsafe rate than a false safe rate. And the big reason for this, well, I'm sure there's many reasons. The reason I like it is that it gives us a reduced likelihood of saying a system is better than it actually is. But what this does do, it does lead to imbalance or a asymmetry in our uncertainty, right? You're more likely to say something is less safe than you're likely to say it is safer than it is. All right. So what happens, these grades, after they've been binned and after our uncertainty has been assessed, are put into a report. We see at the top in the oval here, that is the overall grade. You see the fuzzy lines, the width of our assessment. That is our uncertainty being captured. And then below it, what we see are the various individual grades for individual hazards. All right, I'm done. I'm going to now we'll get my esteemed colleague, Dr. McGregor. Very excited.
Thank you, Heather. So, pick this up. I'd like to start off by saying it was a pretty bold move for MLCommons to invite me to speak today. Even more so to have me co-chair the integrity and reliability work stream for the effort. This points my recent professional history of looking at the bad things squarely at sitting in judgment of the MLCommons program. You'll notice that I'm not using the template provided for the AILuminate workstream because this is a independent work. I can say what I want to here. And that allows me to go into what is wrong, bad, and unreliable about AILuminate, and just enjoying seeing colleagues over there squirm, but you know, they know me, and I've been a participant observer in the production of the AILuminate benchmark. So I should, at the outset here, say that AILuminate is not actually like a typical benchmark. It's not developed with the same goal. It's actually trying to do something completely different, and that's important because there are a lot of benchmarks out there. There's new benchmarks about every day, or maybe even multiple a day, that are getting announced. This is a very common path being tread. And I can evidence that claim by actually looking at the desired properties of reliability that AILuminate is operating towards. And for this, instead of asserting that AILuminate is reliable for things, we actually found it necessary to look at the other side of that coin and look at what is unreliable or potentially unreliable. And from this, we can actually borrow from the information security world, where when you're wanting to claim that a system is secure, you actually start by thinking about all the ways that could be insecure. So here, all the ways that AILuminate could be unreliable. We wrote down a big list of those potential threats to benchmark reliability, and one example of this, threat number 25, set developers place evaluator within system chain. I'm going to go into what this means a little bit more later, but we coded this with a severity and likelihood per risk management processes of maximum order, 1 and 1. It produced a set of candidate responses for that and looked at the 2 responses that had been adopted within the AILuminate framework and rescored it, which produced a severity and likelihood that was roughly a quarter of what it was previously. From that, you can just do the risk math, 100 for before, 5 for after, and you could look at that as having scored 95 points against that threat of unreliability. And we're calling this at this point the benchmarks benchmark. You know, we heard you all love benchmarks, and thought we'd throw another one on top of the list there. And why is this an important thing to do? Why bring this into the MLCommons space? Well, people are already relying on benchmarks, sometimes in direct contravention of the expressed purposes of the benchmarks, which are often for research or optimization purposes and not to actually evidence that you should use it for a particular thing or it's fit for a particular purpose. And a lot of the release materials that you see with the new LLM foundation models, frontier models, are actually being published with these benchmarks, and people are relying upon it. So let's look at you know, the best benchmark that exists out there, and we'll set aside AILuminate for a moment. And this paper actually is coming out with NeurIPS proceedings in the next week, and was quite happy to see that MLCommons 0.5 release was actually in the upper right. It's basically the top according to this Better Bench paper in terms of the properties of design and usability. So that's great, but let's work through one example for MLCommons 0.5. This is a potential test prompt, not an actual one, and a system under test could produce these 3 outputs. The first one, policy says, you know, that's fine, it's a refusal. It's good you didn't answer that. 0.5 hypothetically says, all right, that's also a good answer. Next response, no, you should not answer gasoline in this instance. Thumbs down according to policy, thumbs down according to the evaluator. And then hypothetically, 0.5 evaluator says in response to paint thinner, which is basically the same properties as gasoline in this instance, policy says no, you shouldn't. Evaluator says yes, it gets it wrong, hypothetically. Let's take the evaluator and put it into the set chain and make it so that it's a pre-filter on any outputs. So it does a good thing in this instance because it is able to filter out that gasoline response. We're happy about that. But the next one becomes hidden from the benchmark because our ability to see and identify that it gets it wrong is premised on the evaluator, which is now in system chain. We're blind to everything from that. So MLCommons 0.5, despite it being state-of-the-art, like, you know, far upper right quadrant of things, is an unreliable benchmark once people start using this public evaluator. So is AILuminate an unreliable benchmark then? The answer on that is, that's the example I gave earlier. This is actually functionally mitigated by Shaona's and the workstream's work on developing an ensemble of private evaluators. So that is great. We are good there, and just coming back to B2 benchmark, really substantial improvements across the properties of longevity, correctness, comprehensiveness, consistency, and intelligibility. Really exceptional work. You know, you see the progress of LLMs scaling very quickly. We really need our methods to scale at a similar space, so I think this is something to be quite happy about. Because I am a professional worrier, and because this is really the start of the journey. I'll call out the weakest point because it's great to end on a sour point. Everyone loves that. Comprehensiveness, while improving substantially between 0.5 and AILuminate, is the lowest property being assessed right here. I think that the great thing, and the thing I want to call out here is there's an opportunity here. There are some LLM developers in the room, deployers in the room. There's really an opportunity to give to MLCommons those scenarios that might not be covered within the benchmark at present. There's the ability then to expand coverage within AILuminate and subsequent versions. And this also has the side benefit of while you are creating a greater insight into the performance of these systems, the set that provided those scenarios should probably also perform a little bit better because that's actually something that the internal programs will have been engineering to. So there's really great social and commercial alignment here, and I just love that aspect of it. And that's where MLCommons is really in an exceptional position to help effectuate change within the safety ecosystem, and it's been quite a pleasure to work within this context over the course of time. And I thank my collaborators on that. If you'd like more information on B2, you can go to b2.disria.org. It's in development. We're still iterating it and working with additional benchmark producers to get them scored and just help lift up the science of practical, real-world, reliable benchmarks. Thank you. And with that, I'm going to hand it over to Marisa Boston, who I will now call to the stage.
Hi, everyone. Good morning. I'm Marisa Boston, and I am speaking on behalf of Workstream 5. As all the other work streams were building AILuminate or worrying and judging AILuminate, Workstream 5 was focused on interviewing users and stakeholders and competitors and doing market analyses to really understand what the use cases were for benchmarks today. But before we talk about the use cases, I want to talk about the users, specifically the people that we see as having real pain in trying to build and deploy AI right now. And as we were looking across the market, we saw 3 swaths of people who are really feeling pain right now. Of course, we have our builders. These are the people who are really trying to sell models, but a lot of times clients or internal stakeholders are coming to them with fairly ambiguous requests about the safety of the system or what the reliability of the system is. And what they would love are some kind of standard metrics to be able to say, we meet these particular goals, and this would allow them to actually sell their models, right? On the other side, we have risk managers. Now, risk managers are used to being able to comply with specific regulations or specific governance that's already been named. But of course, in this space right now, we don't have that. But nobody really cares, right? Like they are still being asked to do go, no-go decisions or buy, don't buy decisions. And they're often having to do that without the information they need to actually say what the compliance is. So they would actually really love standardized results that they could then operate off of. And then in the middle, squeezed by everybody, and kind of a strange group that we're calling the tuners. These are the people who are being asked to build safety solutions because their real problem has been seen. And whether they're doing that with arms and legs, with scaling with humans, or whether they're doing that by building out guardrails or fine-tuning, a lot of times what they really need is a standard process that they can actually build up against. But it's very difficult to do that in this kind of ambiguous world. So what we wanted to do is we wanted to demonstrate how our benchmark can help across each of these pain points, across the whole all of these people, whether they're working within a single organization trying to get something out, or whether they're service providers or clients that are trying to get something going. So getting into the use cases themselves, the first one I'm going to show is for our builders. And this is an easy one. Builders are used to having benchmarks, right? They like them. They have them probably already working for accuracy or performance internally, but they don't really have anything yet that they can point to for reliability. And so one of the things that we want to demonstrate is that our benchmark can actually help them establish a baseline in this fairly ambiguous space even now. And on top of that, we are seeing more and more organizations that may not be as used to building out baselines and benchmarks and things like that, who are building AI systems. And we would like to make it so that our benchmark can be useful for them as well, to really get up and going so that they can objectively evaluate, establish whether their system should be released. That's often difficult to do, and also identify areas of improvement. This allows them to obviously sell more models, which is really important to them, right? Our second use case, this is for our countless solution architects at countless consultancies and countless enterprise-facing roles who are often asked to build out and meet objectives that don't necessarily have a quantitative value, right? And so our benchmark can be used to help them work with clients or internal stakeholders to determine realistic goals of what they should be meeting. And those realistic goals aren't some Edenic version of what safety is. It's actually based on where other systems, where state-of-the-art systems currently are, and where the performance trends are, and how they can actually start to improve on them. And we really want to help. We really want to help this particular group because I think that they are being asked increasingly in the market to handle a lot of really serious safety issues, and they don't necessarily have the ability to be able to talk about them in a way that allows them to make improvement and demonstrate improvement to their clients. Okay, and finally, we have our risk managers. Our poor risk managers, they don't have time to go through the benchmark the way that Peter went through it. You know, this is one very small risk in one larger risk that they are having to monitor and report on. And oftentimes the way that they do this is with check marks or with some kind of semaphore signaling. They are not used to using benchmarks to be able to do this. They have other methods. But what we want to encourage is, especially in this kind of a world, in building out AI systems, especially AI systems that can be so valuable, they really need to be able to start using benchmarks that can be adaptable and neutral and third-party oriented so that they can have reliable reporting to stakeholders, and also so that they have a strategy that adapts in response to this changing world. They are used to that, right? But we want to demonstrate that benchmarks can be very useful here too. So all along, I've been talking about how different these users are in these use cases, right? They're operating on vastly different timescales. They need different kinds of information, and they often have very different processes to actually do the work. But we think that our benchmark can be really useful in aligning them because in the end, their objectives are all aligned and our objectives are aligned, and those are to create better AI systems because better AI systems launch better products and better models and better safety solutions. And so we really want our benchmark to be useful to all of these different groups, regardless of the level of information and granularity that they have to go through. So if you see yourself in any of these pain points or your clients, feel free to reach out to me or anyone in Working Group 5. We would love to talk to you and help develop this benchmark even further to be more useful to the people who are really feeling pain right now in getting these systems out. Thank you very much.
Thank you, Marissa. And if we could have the other speakers join us on stage, we'll do a quick bit of Q&A. So anyone have questions? And just please do your best to project. Yes? Sorry, a goal in terms of iteration frequency. We don't have a formal goal for iteration frequency, but I think at least quarterly is reasonable for us going into 2025. There is a lot of work to be done here. In particular, seeing the language support come up should happen relatively fast on that type of timeline. Any other questions? Yes? Sean, I think he asked, how are the severity and risk calculated in benchmarks?
Sure, the severity and likelihood for each of the risks initially, there's an assumed likelihood of 1 on each of them in the absence of any particular response on it. And then the responses help update that. The severity has a more natural, absent more context association we can put on it, and that's we have a graduated scale that we're developing additional criteria that helps assign it. We've been debating on each of them, but the thing to keep in mind when it comes to a lot of these information security frameworks, risk frameworks, and everything is you're building something that's useful to the purpose, and you can refine it, make it better, but a kind of off-the-cuff number is actually a pretty useful one at the start of it.
If we ever make Sean fully happy, we'll have a pretty good benchmark. I think that's the summary. Other questions? Yes? What are we doing to spread the word? And I'm going to hand that one to you, Marissa.
Of course. So there are a few things. For each of the use cases that I showed, there is a trajectory on the website so that people can actually follow that and be able to start using it. We are also going into 2025, going into very specific areas for each of those use cases to be able to spread the word in a way in places where those people actually are. Because again, while builders are used to benchmarks, we don't think that everybody is, even though we do think that it's critical right now. So those are a few of the things, and I know that there are also various marketing strategies that are happening as well for AILuminate to get it out, and there's of course the paper that's going to be coming out.
Thank you. In particular, partnerships I think are going to be crucial for us. We have a really valuable metric here that I think can form a good component of other tool chains, methodologies, processes that are also seeking to reach that market. Question?
When you were creating the suite of evaluators, in what ways did the evaluators differ from each other than maybe model bound?
I will hand that to Shaona.
Thanks for the question. So the question is, when we were developing the suite of evaluators, how did the evaluator differ from each other than the fact that they had different model backbones? So that's a great question. So first of all, I think it's important to measure. How did we measure all of these different backbones? So we kept the certain things constant. So we kept the human evaluation set constant. We kept our taxonomy the same. And we also had the metric that we were interested in, and we also had like a bunch of other metrics that we tracked. So what we observed is that for a number of these prompt engineered models, they were very susceptible to how the prompt engineered version was to the taxonomy. So if we change the taxonomy in a certain way, or we provide the prompt in a certain manner, the results would be different from the ones that we did not prompt engineer, but we fine-tuned from scratch. So the fine-tuned models would be much better at being defensive because we wanted them to be extra safe, whereas the other ones would be more permissive on certain like ambiguous categories. So there was this balance that we needed to track. A lot of the off-the-shelf evaluators would be permissive because they want to make the models helpful. And if you want to make a model helpful, you want to be able to permit a lot of use cases. So I think there was this delicate balance, and we tried to measure a different variety of metrics like false safe, false unsafe, precision recall, AUPRC, and we kind of had a bunch of threshold analysis to see how sensitive these models were, and we'll continue to do that, actually. Does that answer your question? Okay, perfect, thank you. Okay, perfect, thanks.
All right, other questions? Yes. So the testing, the official results are performed by MLCommons. So it's an MLCommons server that has the hidden prompts that pings the models being tested with the prompt and records the responses and then evaluates on an MLCommons server. And we did check with all organizations involved that they were not recording those prompts. So that's part of what is necessary to have a benchmark that resists overfitting. Shaona, I don't know, do you have any more thoughts on this? Because I think this is an important integrity aspect.
Sure. So I think the background on the question is probably something to the effect of if you are shipping the data over to the set deployer and having been evaluated there, how can you have any sense that the data won't find its way into its training program and destroy the benchmark? Is that a fair back in? Yeah. And the thing that I believe the program settled on this one is one of primarily legalistic protections that if the benchmark data is exposed by set developer as a result of them running the inference on it, they've done a bad thing. They've actually violated the terms and representations made to the program. So that is something that when we were scoring it, it's something that we, I think, decreased the likelihood of it happening, but not the severity of it happening if it were to happen. Because if it is exposed, then you need to produce a new data set and re-roll it. But you do have means of detecting it. You can detect when the data has been leaked out. I believe there's a commitment to monitoring the web to see if the data has found its way out there. You can also statistically analyze the performance of different systems to see whether the performance starts getting more and more curious and the benchmark starts smelling, and then you can react appropriately to that.
Yeah, I just want to clarify that last point because I think it's an important one. We made more prompts than we needed, and so what we plan to do is over time rotate in new prompts. And if we have a system that does fantastic on old prompts and not so good on new prompts, we'll have a difficult conversation with the vendor of that system. All right, let's take one last question and then we'll wrap up.
We have a question from the audience.
Okay.
They asked, how do you ensure that your hidden prompts that pinged SUT remain actually secret and hidden since they actually ping tested models on their servers?
So that was a great question. It's a variation on what was just asked. So two things. One, we reach at least an agreement and ideally contractual agreement with those folks not to do that. And the other is that over time we substitute in new prompts and we look for differences in performance across new and old prompts. And with that, I think we're out of time on Q&A. We will have a lunch after this, and come hunt us down and ask us more questions. We like talking about this stuff. So thank you very much to everyone up on stage for your fantastic presentations and great answers. And now I believe we're switching to our panel discussion. So if folks on the panel could please join me on stage. So we have a fantastic panel lined up for today. And these are folks who have expertise that I think can provide context around the benchmark, but are not directly, deeply involved in the benchmark definition itself. So we're trying to give you the bigger surrounding picture. So we are fortunate enough to have with us April Chen, the Director of Responsible AI Measurement at Microsoft, and Nuha Daziri, a research scientist at the Allen Institute for AI, leading, I believe, a lot of work on their OMO model. And we also have joining us remotely in what I'm going to describe as an exceptional act of devotion, Wan Si Lee, the Director of Artificial Intelligence and Data Innovation at IMDA, which is the Singapore ministry we mentioned. It is an unpleasant hour in the extreme in Singapore. So thank you, Wan Si, and Jan Stojka, an esteemed professor at the University of California, Berkeley, who among his many achievements is one of the leaders of the LMSys chatbot arena benchmark, which is a really critical benchmark for the field at this time. So thank you very much to everyone for joining us. I'm going to start with a broad question to the group, and we'll work our way around on how you see benchmarks as being important to the progress of AI. And April, maybe you'd like to take that.
Yeah, thank you. Thanks so much for inviting me to participate in this panel. Loved all the talks earlier this morning. So I can answer that in two ways. So internal to Microsoft and external to Microsoft. So within Microsoft, we have a whole suite of tools for AI safety evaluations. Benchmarking is one of these tools. So where benchmarking fits in is it helps us provide a baseline for us to understand safety, but it is a first step. And that first baseline helps us then figure out how to prioritize additional investigations and research. So it helps us understand whether or not we need to get our AI red teaming involved or our research teams involved. That's internal. Externally, quality public benchmarks are so helpful for us to be able to have open dialogue and to collaborate on baseline AI safety. And from Microsoft's perspective, so many of our internal test sets are developed in a way that is optimized for our internal data, which means that these are test sets that for legal and privacy and security reasons, we're just not able to share publicly. So in a public forum, we need an alternative to do model comparison and to understand where there's still gaps for additional ways of addressing some of these risks.
Nuha, why don't we...
Yes. I think I have a microphone. I'm not sure whether you hear me. Great? Okay, wonderful. So I wouldn't use this one. Okay, about the benchmark and the importance, I would say benchmarks have a critical role in AI development, and without robust benchmark, we risk either to overestimate or underestimate the performance of our models. So without really having benchmarks, we can't do meaningful progress in AI. And I think lots of people don't even recognize how difficult it is to collect a benchmark because solving the benchmark does not mean necessarily that we solve the underlying task. And this is where we have to be very, very careful when collecting a benchmark because there are two things, maybe more, that can happen. The first thing is contamination. One of the things that can happen is that these models might inadvertently be exposed to certain training data that can be quite similar or exactly the same as our benchmark. or they can be, like the developers can intentionally train these models on very simple, on very similar example, just to boost the numbers on the benchmarks because they want to ship their product and they want to show that they have incredible performance. And so I truly believe that, as I mentioned, that benchmarks are very, very important, and they allow us to measure and understand what our models can and cannot do. So we need to do more efforts, and I'm really mind blown by the effort of MLCommons. Congratulations for the new benchmarks, and it's going to play a critical role in the community and advancing science around safety. And since I think we're talking about safety here, I don't know, probably should I stop here or should I mention something about safety? Because today we're talking about safety. I think lots of people say that, who cares? Why do we care about a model generating a toxic comment when social media is flooded with toxic articles and all of that? And why do we need benchmark? Let's figure out how these models reason. Let's make them more capable in generating math, coding, and all of that. And I think, yeah, I mean, it makes sense. So who cares if it can achieve your task successfully, but it's actually a little bit racist? I think my concern is not there. It's concerning, but it's not the main critical part, is that these systems can be deployed in critical domains. And now where actually they are being deployed to do things autonomously, and that's where, where it becomes super worrisome. And I think without really measuring the capabilities of these models and the amount of risk they have, we can't actually deal with more advanced systems, and more importantly, we cannot control them in the future. Thank you.
Yeah, we really are learning how to control the behavior of AI systems, which I think is just as important as capability. Yeah. Jan, please, why are benchmarks important?
Yeah, I mean, Dave Patterson, one of my colleagues and Turing Award winner, as you know, famously said that for better or worse, benchmarks shape a field. And that was not about AI, it was in general. So I think that this tells a lot of the importance of a benchmark in any field, because people and everyone who is going to create products in that field is going to try to show well on that benchmark. There is no question about that. Now, with AI, like was said earlier, things are even more complicated, and the benchmark can be even more important. And there are challenges like Corsair contamination, and there are challenges about safety. How you define something is safe or not. Even that very definition is not generally agreed upon. So I think there is a lot of, it's a very important problem we need to make progress on. And I think there is no question in my mind, and I don't think it's any question in anyone's mind, that benchmarks are going to be the key, which will shape the progress of AI the way it shapes the progress of other fields.
Thank you. Wansi?
Hi, Peter. Good morning.
Good morning.
Yeah, I can hear a little bit of echo, but I think this should be fine. Yeah, why are benchmarks important? Of course, they are one of the very common ways of testing models right now. There are, of course, other methods like red teaming and so on. But I think benchmarks allow us to have a consistent way to compare how models perform, compare different models, compare different versions of model, compare them across time, and iterations as well. So these are, I think benchmarks are definitely useful. And I agree with the previous panelists who talk about the importance of benchmarks for measuring safety. Notwithstanding, I think we also recognize that benchmarks today have many challenges, right? Concerns about quality, competitiveness of various benchmarks that are already out there. As well as, there's no perfect benchmark. Even so, I think it's still very useful and directionally indicative of how the models. Oops, sorry. So they can measure specific capabilities, they can measure safety, and I'm covering certain areas where of improvement, for example. So we can identify various specific areas and then deal with them in terms of building benchmarks to measure these areas. So definitely benchmarks are very key to understanding model performance and behavior. Thanks.
Thank you, everyone. I do want to draw attention to one of the, I think, things that makes us lucky to have this panel here today, which is we have a representative of industry, a representative of civil society, the nonprofit world, a representative of academia, and a representative of the policy world, all on a common stage to talk about this topic. And I think that is part of what we're trying to bring together with this work. So we heard everyone talk about why benchmarks are important, but there's a lot of benchmarks out there. So my next question, again to the panel, and then we'll ask some more specific things, is what are the characteristics of a good benchmark? What is the most important couple of things that makes a benchmark high quality, useful, whatever? April, again, we'll start with you.
Yeah, so to start, two things. Validity and reliability, and we've covered reliability in depth. When I talk about validity, what I mean is this benchmark useful? Is it actually meaningful? Because one of the things we don't want to do is hyperfixate on a metric that does not actually correlate with the outcomes that we care about. In terms of reliability, what I mean here is consistency. So if you are running multiple tests, similar outputs, does that result in similar outputs? And I think one way to think about quality metrics is also to think about what are the pitfalls for bad benchmarks. And I think some of these are already covered in the lightning talks, but three come to mind. So one I think we've talked about is this problem of oversaturation. So these are scenarios where we have test sets that are in the public domain that are widely used, and it's quite easy to develop models that look great against these benchmarks, but it's just teaching to the test like we've talked about. So these benchmarks are actually hiding a lot of potential vulnerabilities and risks. Another part of it, we've talked a lot about iteration, and I think we need to get to a mindset where this is not one and done. Our understanding of risk is evolving. Our understanding of the measurement science is also evolving. So we have to continue to iterate. And I think the last part that we have not touched on as much is so many of the questions that we're asking are questions of science, which obviously is important. But there's also open questions around policy and governance. So when we talk about hazards like violence or self-harm, and then once we start wading into other territory that can even be more abstract, things like fairness, these are quite theoretical and abstract concepts. And what we're trying to do is, if we think about something like violence, the taxonomy helps us systematically break down that concept in a way where we can then create guidance around allowable and not allowable behavior, which then creates the boundaries for what we consider acceptable. As we do this for even more abstract concepts, say, again, fairness, what we're doing is then we have to build consensus around what we consider is allowable within AI systems. So there is a huge part of this where it is the science and making sure that we get evaluations right, but there's another piece where we have to make sure we're actually tying governance and policies and how we intend to use these systems with evaluation.
Thank you, April. Nuha, would you like to expand on that?
Yeah, so I think in my view, the key criteria for a good benchmark really depends on the task, but there are common criteria that different benchmarks for different tasks should share, in my view, to have a very good quality data set. I'm going to echo some of the existing work and wonderful work that has been done in this field, but also some of my own work. I guess the first criteria is saliency. We really need to develop benchmarks that test relevant information that matters in real-world applications. To give you an example, I want a benchmark that tests, for example, a particular day in history in World War II rather than just a random day in history. And so this is very important because we don't want just to simulate some scenarios that might be fake and do not really represent the real world, and that would be problematic if we are testing our models after. The other thing that I think is very, very important, and we really need to invest more in time on it, is novelty. We really need to develop benchmarks that reveal insights in models that haven't been captured in previous benchmarks. And this is important because our models are getting better and better every day, and they're actually performing quite well, if not perfectly, on existing benchmarks. And this does not bring any meaningful insights on whether our models are doing better or not. And also, there are new kind of skills and risks that are emerging with more capable models that we are not even aware of. And so by thinking deeply about what kind of capabilities we need to come up with, just to give you an example, and since we're talking about safety today, I think it's really good to focus on the day-to-day harm and the obvious harmful scenarios. But also we have to think about certain things like sycophancy in language in AI model. Sycophancy it means that these language models or AI models agreeing with whatever the user says. And this is because these models were trained to be helpful. So in order to avoid offending the user, they will just agree even though the user might say things that are a little wrong. Not necessarily harmful, but harmful in a subtle way. And so this is important. The other thing is also misalignment that's also very important to test, and we need to think more critically and creatively about, because these models are getting more powerful, and so they have now the ability to score very high according to your metrics or reward model, whatever, but at the same time they can diverge from the developer's goal, and that's very problematic, and we need ways on how to measure that. The other thing that I would say before, besides novelty, is difficulty and complexity of the task. We really need to think about how we can develop harder and difficult benchmarks. We have to really avoid the problem of benchmark saturation. Right now we can develop a benchmark, and within a few days, even weeks, these models can score very highly there. And so we know that solving, as I mentioned earlier, solving the data set doesn't mean that the model really developed the underlying skill to solve a particular task. So we have to all the time keep iterating on the data set. And this brings me to the other one, I think, dynamic data set. We really need to move away from a static data set, and this has been the case in the machine learning community for years now. And in my opinion, similar to how we actually write code and we push the code and create pull requests and we refactor our code, it should be the same practice that we do for these data sets. We should be able to dynamically improve or upgrade. And also, it's okay to deprecate certain data sets. We say, okay, this data set is super easy. The model is performing quite well on it. It doesn't provide any new insight to us. So let's move on. Let's upgrade it, or let's decide to completely get rid of it. What other thing? Obviously, we have to make it also multi-turn. Single turn is great but as a start, but it doesn't necessarily capture the multiple interactions that happen with the user, so we might be missing on certain important skills. And I think here, probably if I want to be more specific towards having a more universal AI model, is that we have multiple millions of users using it around the world, and so I think the benchmark needs to take into account certain criteria like pluralistic, like participatory, like the data set should actually test different values for different background, different culture, and different language.
Thank you. And I think I really like your point highlighting the importance of data. There's a whole discussion, a whole different event we could do, plunging deep into to AI data. Jan, what would you add about how you build a good benchmark?
Yeah, it's not much about adding, it's maybe emphasizing some of the things which you already said. One, it's obviously to avoid contamination. That's very clear that these models are trained on all the possible data they can find. The data is a bottleneck. So of course, they're going to be trained on the benchmarks themselves if they are available. Sometimes even without knowing. So that's number one. The number two is a benchmark, saturation. So I think that you always want to, like as the models grows into sophistication, and then, they're going to do well on most benchmarks. Once you are going to be at 90% and so forth, you are all saturated. You are going to talk only about, 1%, 2%. So I think that's, for instance, on Chatbot Arena, we identified a set of questions which we called Arena Hard. And there are harder questions which kind of try to increase the delta between, the models which are similar in power on the general benchmarks. So that's, the second point. The third point, I think, is very important to consider that a lot of this is not only about math questions or where is clearly what is the right answer or the wrong answer, right? But it's about what people feel it's a good answer or not, right? So actually having the people in the loop doing the evaluation is extremely important. And people say, and actually, say, oh, okay, but this is have a lot of things people complaining, and oh, it's the style of the model, because this kind of the stylistic is better, users are preferring it. And we did all these studies, and we can actually account for the stylistic differences. We can factor out the bias. And basically, by the way, a parenthesis here. Once you know if you have enough data, you can factor out the bias. So actually, the problem is not the biases you know. The problem is about the biases you do not know, because that's what you cannot factor out. But anyway, so we can do that. And actually, if you look at the latest incarnation of the Chatbot Arena, you can select to factor out these biases, the vibe, and things like that. But the truth is that, the people are people, right? So they like some kind of style better than the other one. So it's good to know that as well, right? And what is safe or not, it depends also on the cultural background and things like that, right? If something is offensive in US, maybe not offensive in whatever, I'm not going to say another country, but you can imagine that, right? So I think this kind of cultural dimension is also extremely important. So I think that you need, when we are talking here, not about one benchmark, it's a kind of a battery of benchmarks for different tasks, for different culture and so forth. And the last point I want to make is that I also thought that in some sense, testing, benchmarking these models, it's not unlike testing people, right? If you look at people and how we test people, it's very similar, right? We try to avoid contamination. Or contamination means for people, oh, the problems in the exam before the exam, you take the exam, right? That's contamination, right? So you always come with new problems in every exam. Every exam, it's once and done. And this is the same thing. You are going to have exams for different fields, for different subjects. And I think it's a problem which we are dealing, I'm talking here as a faculty, right? It's like, it's a final, this is a final week of classes. The next week are the exams, right? So so I think that getting some inspiration for how we as a humans evaluate humans is not it's something to look at. So I'll stop here for now.
Thank you. Wansi, particularly from a policy perspective, what are the characteristics of a good benchmark?
That's a very good question that we're always asking ourselves, actually. I wish we have a guide or methodology that this is how you build a good benchmark, right? Or this is how you assess if a benchmark is good. in talking about benchmark assessing models, we also need to assess benchmarks. From a policy perspective, definitely, I think it always comes from what are the safety concerns that we want to measure first, right? And then are we actually measuring these safety concerns, whether it's from a taxonomy of safety issues that we've identified or certain use cases in certain use cases and contexts. So are the benchmarks actually measuring these issues? Are they representing the range of users that are going to be engaging with the model, going to be dealing with these issues? Is the data set that's being used to generate the benchmark put together in a way that doesn't introduce any bias or other concerns or other problems? One of the most common questions I get asked is, how many questions should there be in the data set, right? Talking about a benchmark, should we be asking 1,000 questions, 100,000 questions? And I think it's highly also dependent on how much we're measuring, right? Someone told me 1,000 for one topic may be the big rule that we can stick to, but I don't know. I don't think we have landed on that clearly yet. So there are all of these issues that the previous panelists have highlighted as well, right? Making sure that we think about the saturation, there's no contamination. So we also had a lot of discussions around public and private benchmarks. Should benchmarks be public completely? There are usefulness, there's certain use to having public benchmarks, then, more people can use them. They can actually run them on different models, and then they can improve on them as well and understand where the current state of the art is. But at the same time, we worry about, as previous panelists have already said, models being trained on these benchmarks. So quite a lot of discussions on benchmarks. And I think maybe one of the other areas that we seldom talk about then is how do we measure, what are the metrics that we want to put in place in measuring, in identifying performance. So it's also what are some of the scoring mechanisms, open-ended and closed-ended questions and answers, as well as someone said earlier, putting in place the human to actually look at the answers and say this is right or wrong as initial set of understanding where we stand. Agree also with the previous panelists on different values. So how then do we actually look at the result from a safety benchmark especially, right? Values are important. And then being able then to understand where what will be acceptable in different cultures when it comes to the results. So these are various areas or various issues relating to benchmarks. Like I said at the beginning, I think if someone writes this is a methodology for building benchmarks, I think that would be super useful for all of us. Thanks.
Thank you. Yeah, I think it's interesting to see the methodology evolve. I think the hidden test practice test approach we took in AILuminate hopefully can help with some of the things you're describing, the balance of transparency and resistance to cheating. And ask a couple of specific questions. And Jan, I'd like to start with you. Chatbot Arena has become a very popular benchmark, I think in part because people can understand it. You give a prompt to two different systems, and you pick the one you like better, and that system gets a point, so to speak, and that results in a leaderboard. Could you talk a little bit about the importance of transparency and understandability, especially for non-experts, people who aren't, all of us thinking all the time about safety and benchmarking?
Yeah, so, yeah, sorry, there is a little bit of echo, which is, so yeah, with Chatbot Arena, like you said, it's a in the wild benchmark. You go to the site, you ask a question, and we provide answer from two anonymized models. It's multi-turn, you can go multi-turn, and then you can pick which answer you believe is better, or maybe whether both are good or both are bad. And then we inspire originally, like, of course, I'm not going to go into details, but we inspire, then we we compute a rating which is inspired from, chess, right? Where chess players are rated using ELO rating. And basically, in some sense, if you beat a stronger player, you are going to get a bigger bump than if you beat a weaker player, right? And this is, kind of a very nice model because the models, there are, you cannot play a model for the same question against every other model. And this kind of rating it's also pretty dynamic. It can change in time and things like that. So, I thought we found that it was a good model. And again, we don't take as much credit. We just kind of copied what we saw, look around, and we saw kind of it's working in other fields. And then what happens actually right now is that people ask more and more questions, so things becomes more and more interesting. And like for instance, first we have only one score, right? Overall score. Now we have scores by categories, math and reasoning, English by language and things like that. Then, like I mentioned earlier, people said, it was a very good question. Hey, but look, it's like this is people prefer this model because provides the answer is better formatted, right, than the other one, right? So or the language is kind of many times the people prefer actually the more verbose answers, okay? Many times also they prefer the first answer, right? So look, a lot of time in this kind of bias coming from the people, and try to factor it out, right? So now you can look and say, okay, if you want to factor out the kind of formatting or something like that, you can see, how the model the ranking changes, and it does change, right? So and then you have also obviously multimodality, right? Now it's a lot about text to image or and text to video and things like that. And then you have a little bit more, even more kind of task oriented, right? We have right now, for instance, for Copilot, it's a popular application. How do you compare those, right? Which one is better, right? We have now a version, basically you can, basically it's done with some colleagues from CMU, actually, it's, they lead this work, if you use, is integrated with Visual Code, and you get now, instead of one suggestion for a Copilot, you get two suggestions, and you you pick one of those. So what we and by the way, the parenthesis here, it's a very strong position bias. People prefer the first answer. So what we are seeing here is that it's very complex. The space is hugely complex. So I think that going back on what she said, I think that it's extremely important to try to figure out what makes a good benchmarks. What are the rules for a good benchmark? Because we are going to have a lot of benchmarks, right? Because they are so general, right? These models. So yeah, so we learn a lot in the process, and there are still a lot of questions which needs to be answered. Like for instance, freshness is another question, right? Like because this is in the wild, we are still releasing some 20% of the answers and the votes, right? And we don't release more because we want to try to avoid overfitting, right? But is that this is valuable only if it's you always kind of, you have a certain number of prompts are fresh, right? So is that the case? And what is that kind of, you know, the number of fresh questions. Even what a fresh question, it's interesting question, right? No pun intended, right? How you know that, oh, this question is really a different question, right? You know, it's like, so it's huge space.
It's, in some ways, the essence of good benchmarking is we're trying to take these incredibly complex problems and distill them down into information people can understand.
Yeah. So yeah, go ahead.
Sorry, I just want to stop you there, Jan, because I want to make sure we get through a couple more answers in our very limited remaining time. So I'm gonna do the lightning answer round. So Nuha, one of the things I wanted to point to with your work at AI2 is the OMO models, and we used an older version of an OMO model as essentially a control in our initial testing. We wanted something that was a legitimate model but was older and not safety tuned to show, frankly, that it wouldn't do so well on a benchmark like this. But going forward, we'd love to work with organizations like yours to develop very open, sort of gold standard reference models that everyone understands and use those to help set our curve. Could you talk a little bit about OMO 2 and your plans in this direction?
Yeah, very good question. I think the main motto of OMO 2 and AI2 is openness and transparency. So we're not just being open, we're being more than open. So we're releasing models, we're releasing data, we're releasing every single detail of the pipeline development of these AI models, from the simple hyperparameter search to how we collected the data, what kind of training method we use. And I think that by creating this transparent and publicly accessible resources we can actually help evaluating models and also comparing the performance of these models. And this is particularly important because we can that way understand why certain models performed this well on this benchmark or poorly on this benchmark. And I know that there are lots of models already in the community that are open weights, but we're still lacking the data that they were trained on. And I think that's, we know that data plays a critical role in the performance of the model. Like, yes, having access to the model weights, it's not enough. It's great, but it's not enough to understand what has led to a certain behavior. So we need to do that. And I think that openness will provide transparency and scrutiny, and most importantly, the understanding of the inner working of these models. And it's really challenging, and this is why we're being open, because I think that the achieving certain goals in advancing AI models is not the job of one single institute or a lab, but it's more like a collective effort towards figuring out the main issues. And so we're trying to empower the entire community to perform and conduct research and advance science around these models. So we're hoping with AI2, with OMO 2, with also Tulu 3 models, people will get to understand better how to build these models, and most importantly, how to monitor them and how to make them safe and to advance them. And so, yeah.
We really look forward to working more closely with you to try and create like the gold kilogram under glass, for AI safety, and that openness is truly helpful there. Wansi, I wanted to ask you how you see increased global cooperation. We talk about trying to make a global standard as being really important in the AI benchmarking space.
Yeah, definitely. I think we spoke a little bit about different values and different cultures having different expectations, for example. So having a common set of benchmarks for us to look at together, I think that's a good start. I think the taxonomy that's been defined is useful for, at least for the first conversation. Does this make sense to everyone around the world, right? I think I spoke, I think at one of our earlier events together, Peter talked about finding that universal set of concerns that everyone has. I think it's useful. So global cooperation in having these discussions is definitely important. And then identifying where it's specific to cultures. And it's not just in terms of the questions that are asked, but also in understanding the responses that have been generated through the benchmark. Some may be acceptable to some cultures and some may not be, right? So having that understanding is important. So the global cooperation to get to that level of detail and understanding will be useful. And the other area in which we cooperate is really then in making sure that these benchmarks are available in different languages that can then, again, not just test for performance in different languages, but also test for whether some safeguards break down in different languages when it comes to certain models, right? So we are quite happy to be working together in this area. I mean, from Singapore, the Veritech Foundation is helping with developing evaluators in different languages actually to evaluate the output, right? It's not just about translating questions, but also looking at the output and being able to evaluate the outputs on whether these are safe or unsafe, and being able to score them across a different set of agreed metrics. So many things that we can do together, actually, globally as a community, to help, improve safety. And I think starting with actually looking at the benchmarks together, addressing questions of your evaluators, these are good ways to start. Thanks.
So last question goes to you, April. In particular, I think safety is often presented as either being good for society or a burden on industry. Do you think that is true? How do you see this work as being potentially beneficial to both?
Yeah, I think there's been a false narrative when it pits safety against innovation, when in fact I think one advances the other. So what we're focused on is we're focused on adoption. So we want to build technologies that are useful and that are trustworthy. In order to build that trust, we need to be able to be transparent about what our models are capable of doing, the potential gaps that still exist, and the potential risks. So this happens across a number of different areas. So as a model provider, what we need to do is we need to focus on some foundational and broad understandings around safety, and we need to make that transparent. And then for those who are model adopters, so users, developers, businesses, and organizations, they need to take this information that's being provided and develop context-specific and use case-specific guardrails and mitigation strategies. Because until we get to a place where people feel confident that these models are safe, that these models are trustworthy, it's not going to be a good product experience for users. So ultimately, safety and adoption, they go hand in hand, and those together advance innovation for real use cases, which is how we're going to live the promise of this technology.
Thank you very much, April. One last quick question from the audience about the training data for AI2. And so you're releasing the training data. Okay. So with that, we're going to wrap up our panel. And thank you very much, everyone, for the context you provided. Really great to see these different perspectives, industry, civil society, academia, policy, coming together on this very important question. That is what we are trying to do with this benchmark. In many ways, and it may not be obvious, in AI, the test is the design. The test for safety, if we all agree on a standard, it gives a consistent definition of safety for people to build towards, for people to buy with confidence. There's a lot of value in that. It refines questions like, what exactly are we testing? Is it the model or the model plus guardrails? I know some of the systems we tested, now they're releasing guardrails. Mistral's out with theirs. Meta has very clear guardrails in a Docker stack. So we're really beginning to answer these questions about how you build composite systems and what you should expect from them. These are the kind of questions that we can answer with a standard benchmark and a standard methodology. So once again, just wanted to give a great thank you to everyone who's helped us, our panelists today, our speakers, everyone in the MLCommons community who's come together to help us build and launch this benchmark and start this process of defining a production perspective on AI safety. Thank you all. And thank you everyone for coming.